All right, so now at this point, we're going to look at simple distillation, right? Simple distillation and fractional distillation are two separation techniques that always comes back in your paper too. All right, so let's move on to that slide. Let me explain it, and then I'll show you an experiment based on such. So we have here our setup for simple distillation. Now, if you want to get a particular, how you call this thing, a particular solvent from a solution, you can carry out this technique. So simple distillation is used to separate and retain a solvent from a solution. So let me say, for instance, you have pure water and you want to get, you have seawater, sorry, and you want to get a sample of pure water from it. You can use this experiment. So let's look at the setup here in front of us. We have a round bottom flask with a little opening, right? There is a rubber bong, that's a cork. You have a thermometer. You have your solid and liquid mixture inside of here. Wire gauze to prevent the flask from being directly in contact with the Bunsen burner. This is the tripod stand. You have a condenser connected to the flask. The purpose of the condenser is to cool vapors. That now is connected to a conical flask. So what's going to happen is when you put your seawater, using seawater as the example, you put your seawater there inside of your round bottom flask and you start to heat it. Remember, you had to recall now you're changing between states of matter. So when you take a liquid and you start to heat it, it turns into vapor. So it's going to start to evaporate. That vapor is going to travel up to the neck of the flask and go through this little piece here and end up in the condenser. Let's recall what condensation is. Condensation is when you're cooling a vapor to get a liquid. So in the condenser, you have cold water coming in, and that cold water is going to cool down the vapor that's inside of there. The hot water is going to be emitted, then you have the cold water coming back inside again. When it cools the vapor down, the vapor becomes a liquid, and the liquid is connected here and collected in this conical flask as the distillate. We call it the distillate. So if it is, we have seawater here, the water starts to actually evaporate. The salt particles remain to the bottom of this. It's going to evaporate. It's going to move up through the neck of the actual flask itself, come down here through into the condenser. The vapors are going to cool down, and over here you're supposed to get pure water. Now, at this point, I would like to show you a video because this is supposed to be done in schools, right? So let me get a video to show you.
Simple distillation. Simple distillation is a method used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. The distillation process involves heating a liquid to its boiling points and transferring the vapors into the cold portion of the apparatus, then condensing the vapors and collecting the condensed liquid in a container.
Right. So this here is your practical setup of what the actual separation technique looks like for simple distillation, right? Anybody has any questions here based on simple distillation?
No, miss.
All righty. So let's take down simple distillation. All right, so when you're finished here, all right, so let's move on. So we're looking at fractional distillation. So when you have two liquids that mixed in each other, we use this. But the two liquids is typically have distinct or different boiling points. So we use this to separate petroleum, right? To be able to get crude oil, to get like petroleum, kerosene, etc. Different fractions. We use it to separate things like alcohol and water, any liquids that mix together, right? So we have here a typical setup. So you have your thermometer inside of what we call a fractionating column. The fractionating column contains glass beads in it that provides a nice large surface area to separate your the, how you call this thing, the two types of mixtures from each other, right? The two different stuff. You have your round bottom flask and it's connected to a condenser. So when you heat the liquid mixture, the vapors are going to rise up into the fractionating column. The one that boils at the lower boiling point will be separated first. So like we say water boils at 100, alcohol boiling at, like we say, 97 degrees Celsius. Alcohol vapors are going to go up first into the fractionating column, go down into the condenser. The condenser will cool the vapor and it'll be collected. When that is done now and you see the temperature start to raise again, you move your flask out, you put a new one to collect, and by this time when the temperature rises to, let me say, 100 degrees Celsius, you're going to see more vapors going to go up here. You're going to see the condenser cooling the vapors and you're going to collect your water. So with fractional distillation, this is used to separate and retain two mixtures, right? Two liquids that are mixed together with distinctively different boiling points. Does anybody have any questions?
No, miss.
Now, this is a real ancient piece of separation technique. I don't even know how many schools still have a separating funnel. I didn't have one in secondary school, but it's when I went to university, I actually saw what the hell it was and actually learned how to use it because them had everything in UTT. So a separating funnel is used to separate two immiscible. Immiscible means that it can't mix. Miscible means to mix. Immiscible means it ain't mixing. So like oil and water. If you have a mixture, the two of them, and you want to separate it, this is a method you could use. So you have your funnel. The separating funnel is usually be a glass funnel with a little opening to the top. The reason why you have that little opening into the top is to allow air to help the atmospheric pressure to be able to help the gravity to drain, right? The separating funnel is shaped like a cone so that none of the actual liquid itself will stick onto the sides of the actual apparatus. It allows all the liquid to go downwards. It reduces the loss, right, of that liquid interface. The lighter density liquid will float. The heavier one is going to sink. So if it's oil and water, the oil will be on top, the water will be underneath. The bottom of the funnel have a little tap. So you just place the funnel over a collection flask, be it a conical, a beaker, or whatever it is you want to collect your particular, how you call it, mixture in, right? Your liquid in. So you put it, you turn on the tap, you let the water drain out, you close the tap, you change the actual collection flask, you put a new one, you open it again, you get your oil. And real simple, ancient, but simple, right? So this is our separating funnel. Anybody has any questions based on the separating funnel?
No, miss.
All right, so just give me a minute. I want to find a video before we look to restart, right? Hold on. So we're going to look at that video here with separating funnel. the tap is closed. I see tap. Can you wear your liquid burning out on you? Place a funnel onto the top of the separating funnel. All right, so you're using benzene and water, right? Benzene is an oily liquid, right? We use it as our base to create different solvents, right? It's our organic as our organic compound. And water. So like I said, benzene is oily, so we mix the two of them and we throw it into the separating funnel now. You see the benzene on top, one of them on top, one underneath, right? So let's see what's gonna happen here. So they leave it to settle a little bit so that the two components separated, right? So you see in two layers there. Okay, two collection plus A and B. Turn on your tap. Like the liquid. Tap is turned on. Liquid started draining. Close tap. Switch on the collection glass. I'll just explain to you what I was telling you, right? The benzene and the water, when it left to settle, it forms separate layers. And they just basically show you how to collect each one of them, right? Anybody there has any questions based on that?